In 1999, a 65-year-old woman with advanced Parkinson's disease lay on an operating table while surgeons adjusted an electrode inside her brain by 2 millimeters. Within seconds, she was sobbing, telling the room her life wasn't worth living anymore. The moment they moved the current back, she was smiling again, asking why everyone looked so worried. Neurologists still cannot fully explain how 2 millimeters of tissue could flip a stable, lucid woman into suicidal despair and back, instantly, repeatedly, on command. The structure they were stimulating is called the striatum, buried deep in the center of the brain, roughly the size of a walnut, split into two halves. For decades it was filed away as a simple traffic controller for movement, the part that lets you reach for a coffee cup without thinking about it. The woman on that table was part of a routine procedure, deep brain stimulation, meant only to quiet her tremors. Her surgeons at a hospital in Grenoble had done dozens of these implants. Nobody expected the electrode to touch anything but motion. Then came the first anomaly. Every time the stimulation reached that specific spot, her mood collapsed on a timer, not gradually, but within 4 to 5 seconds, like a switch. She used the word disgusted about herself, about existing. She wept without an accompanying thought she could name. There was no memory, no trigger, nothing she was thinking about that would explain the grief. When the current stopped, the sadness didn't fade out. It simply ended, like a scene cutting to black. Doctors had seen depression follow brain injury before. They had never seen it appear and vanish inside 90 seconds twice, from a wire 2 millimeters off target. The obvious theory was straightforward. They'd nicked a mood circuit by accident, some wiring for depression sitting adjacent to the movement pathway, and moving the contact back had simply avoided it. Case closed in theory, just recalibrate the electrode, log it as a near miss, and move on. That's how it was written up at first. A cautionary tale about surgical precision, filed under known complications of deep brain stimulation. Millimeters matter in neurosurgery. Everyone already knew that. But here's what makes that explanation collapse. The striatum doesn't have a dedicated sadness wire running through it. It's not modular like that. What sits in that region is part of a loop connecting movement, motivation, and reward. The same circuitry that lights up when you crave a cigarette, that misfires in obsessive-compulsive disorder, that goes haywire in addiction. There was no separate mood cable to nick. The sadness wasn't a side effect of hitting the wrong target. It came from the same tissue believed to govern simple habitual action, meaning something inside the mechanics of how the body moves was also somehow manufacturing despair. Which brings us to the deepest problem, the one still sitting unresolved in the literature. The striatum is where scientists now believe a huge share of what feels like free will actually gets assembled, not decided, assembled after the fact. Patients with striatal damage develop something called utilization behavior. Shown a comb, they compulsively comb their hair, whether they want to or not. Shown a cup, they drink from it, even if they aren't thirsty, even if it's already empty. The environment reaches in and pulls the action out of them, and they report feeling like it was their own choice the entire time. If a walnut-sized structure can generate the felt sense of choosing, using nothing but a pattern of electrical timing, then the 2 millimeter woman wasn't malfunctioning. She may have been showing us the machinery is always running, usually invisibly, always underneath, and we only notice it exists when a wire brushes against it directly. Since then, researchers have tried to explain it away. Some argue it's simple current spread, electricity leaking into a nearby limbic tract, nothing to do with the striatum's real job. Others point to individual anatomical variation, that her particular brain happened to route things unusually, and it wouldn't happen in most patients. Both explanations have been tested. In follow-up cases at other centers, the same 2 to 4 millimeter margin has triggered nearly identical mood reversals in patients with completely different brain shapes, different surgeons, different equipment. The unusual anatomy theory doesn't hold up when it keeps happening to people who aren't unusual at all. What nobody has produced is a model of the striatum that explains why movement, reward, and the raw feeling of wanting to be alive all appear to root through the exact same few millimeters of tissue, close enough that a surgeon's careful, routine adjustment can, for 90 seconds, decide whether a person believes their life is worth continuing. The electrode has been moved back. The tremors are controlled. But nobody has explained what that circuit was really doing the whole time it stayed silent, or what it's doing in the rest of us, right now, while we call our choices our own.